Assalamualaikum warahmatullahi wabarakatuh and salam sejahtera. So during week 9, we will learn about the Rolle's theorem and mean value theorem. So Rolle's theorem is any real value differentiable function that attains equal values at 2 points and have at least one stationary point where somewhere between them is a point where the first derivative is 0. Means the slope of the tangent must be equal to 0. The meaning is when you have a function of f(x), so let we replace the variable x with c here. Okay, so when you replace with c, so you will get f prime c. When we find the derivative for that function, so we will get f prime c is equal to 0. So let we look at the example. Okay, so in Rolle's theorem, you're supposed to have a function of f(x). Okay, then that function f(x) must satisfy 3 conditions in order to satisfy the Rolle's theorem. The first one is f(x) is continuous on the closed interval AB. Okay, the second condition is f(x) is differentiable to the open interval AB, and the third condition is FA must be equal to FB. Okay, so if you find the derivative for FC, okay, so you will get f prime c here. So f prime c is equal to 0. Okay, so in Rolle's theorem, you must satisfy that this condition, which is f prime c must be equal to 0. Then you are given in the question basically in the interval a and b, and the value of c is in between a and b, which is a must be less than b and a must be greater than c must be greater than a and c must be less than b. So in other words, f(x) has a critical point in AB. So if you look at the example 12 here, so the Rolle's theorem states that f(x) is differentiable on AB. Okay, so the continuous on closed interval AB, so FA must be equal to FB. So the question started from here. Okay, so basically you are given the function. Okay, so from this example, you are given the function of f(x) equal to x squared minus 3x. Okay, so you need to find the value of c in the interval of 0 and 3 that satisfy the Rolle's theorem. So when you are given the question, so first thing what you need to do is first you write down back the function, original function given to you, which is f(x) must be equal to x squared minus 3x, and the interval given is 0, 3. So first you state here your a must be equal to 0 and your b is equal to 3. Okay, so from here we replace the value of x here with a, which is a is 0. Okay, you put a here, substitute into the given function. So f0 equal to 0 square minus 3 times with 0. So you solve for it, then you will get f0 equal to 0 here. Okay, for the second one, when we replace the variable x equal to 3 into this function, so you will get 3 square minus 3 times 3, then you will get 0 here. Okay, so from here, we identify that our FA is equal to FB. So hence, FA equal to FB satisfy our third condition here, which is FA equal to 0, FB also equal to 0. So next step, this is second step. You replace the function with the interval given FA and FB. So our third step here is you find f prime c. Okay, So from the given function f(x) equal to x squared minus 3x, so we differentiate this function, then you will get 2x minus 3 here. Okay, then you replace the variable x with c, then we will get f prime c is equal to 2c minus 3. Okay, so from here, you make your f prime c is equal to 0. Okay, so our 2c minus 3 that we have differentiate above, make it equal to 0. Then we will solve for it and make our c as a subject. So from here, 2c minus 3 equal to 0. So 3, negative 3 go to the right hand side, become positive. And we only want c at our left hand side. So means divide. Okay, so we have multiply here at the left hand side, then go to the right hand side, it become divide. So c become equal to 3 over 2. Okay, so 3 over 2 is equal to 1.5. Okay, the value of c that you have get, okay, make sure the value of c that you have get is the interval of 0 and 3. So which is c is equal to 1.5. Okay, then the value of c here you need to write down like this. Okay, which is you need to write down the symbol like this. This is symbol for subset. Okay, so c is equal to 3 over 2 subset with 0, 3 close interval, open interval. Okay, so this is the step we have. 1, we write down back the equation given. Second, we substitute the interval into the given function fa and fb, and we find that both must have to the same amount, okay, same value. Then from here we proceed to our third step. We differentiate. Okay, after differentiate, we make our, okay, fourth step. After differentiate, we make our c must be equal to 0 and find the amount for c. Okay, then the fifth step must be our c is the subset of 0 and 3. Okay, you just write down back the interval given in the question here. Okay, okay. So next, we look at example 13 here. So example 13, okay, the question start from here. You are given the function. Okay, doesn't matter what function you are given. Gx, fx is only the name of your function. Okay, so for this example, we have our gx equal to x cubed plus 2x squared minus x. So we want to find the value of c in the interval of -2 and -1 that satisfy Rolle's theorem. So when the question want to satisfy the Rolle's theorem, so you just follow the 5 steps that I have mentioned previously. Okay, the first step, you just write down back the given function in the question. So gx is equal to x cubed plus 2x squared minus x. Okay, so the given interval is -2, -1. Remember, when you are given the open interval or closed interval, you just follow from the question. So for this question, you are given closed interval, so you just write down back the closed interval given. Okay, so our second step is to substitute our interval into the given function. So the value for a is -2 and value for b is -1 here. Okay, so we just substitute -2 into the given function above. Okay, so when we substitute -2 into our function of gx, we will get -2 power of 3 plus 2 times -2 squared minus -2. So when we solve for it, we will get our GA or G -2 is equal to 2 here. Okay, so next we replace our x with -1 since our value for b is -1 here. So when we substitute -1 into the given function, -1 to the power of 3 plus 2 times -1 to the power of 2 minus -1, then we solve, we will get our GB must be equal to 2. Okay, so from here, we identify our GA value, which is 2, equal to GB. Okay, so means that satisfy the Rolle's theorem. Okay, so when you solve for number 2, you will get both value for interval GA and GB, same value, that means it satisfies Rolle's theorem. Okay, next, after satisfy the Rolle's theorem, then you proceed to the third step. Okay, what is the third step? Okay, so the third step, you just copy the given function of gx, then you differentiate it. Okay, so you differentiate of gx. Okay, our gx is x cubed. So when we differentiate x cubed, we will get 3x squared here. Okay, 2x squared, when we differentiate, we will get 4x. Okay, negative x, when we differentiate, we get -1. Okay, so the variable of x here we replace with c. So what happened to our given function? So g prime c is equal to 3c squared plus 4c minus 1. Okay, so then you solve for the fourth step, which is our fourth step. You must take your differentiable above and let it equal to 0. So from step number 3, that you have get 3c squared plus 4c minus 1. So we just put equal to 0 here. Okay, so we solve for the value of c. Okay, so for this question, you cannot solve by factorization. So you need to use the formula of c equal to negative b plus minus square root b square minus 4ac over 2a. Or you can solve by using your calculator. Then you will get your c is equal to 0.215 or c is equal to negative 1.549. Okay, so from here, we want the value of c must be in the interval of -2 and -1. Okay, so what's mean by -2 and -1? And we have the closed interval here. Okay, the closed interval means when we have the symbol of inequalities here. So our value of c must be greater than or equal to a, or our value of c must be less than or equal to b. So we have two value from the step number 4 here, but we only take the one value which is suitable for our interval, which is our interval. The value of c must be less than or equal to -1, or our value of c must be greater than or equal to -2. So the only value that will give us this in this interval is -1.549. Okay, so -1.549 include in this interval -2, -1. So you must write down subset here. Mean value theorem. So what is mean value theorem? Mean value theorem tells us that two slope, okay, if you have two slope, then two slope must be equal in order that words or the second line connecting A and B and the tangent at line X must be equal to C or must be parallel. Okay, so if we look at this graph below, so this is like the mean value theorem means, which is when we have two functions, so these two functions must be parallel. Okay, which is the tangent line of X must be equal to C. Okay, so we look at the example for mean value theorem here. Okay, so mean value theorem. Okay, suppose that fx is a function that satisfies both of the following. So the first one is our f(x) must be continuous on the closed interval AB, and the second one is f(x) is differentiable on the open interval of AB. Okay, so such that there is a number of C. Okay, so number of C which is f prime C. So this is the following formula that you need to remember. Okay, which is our f prime C must be equal to fb minus fa over b minus a, which is the interval given of a and b, and in between a and b must have the value of C, which is C is the value of C must be less than B, or the value of C must be greater than A. Okay, so for example, okay, basically in the question you are given a function. Okay, it's like Rolle's theorem previously. Okay, so the given function for this example is our f(x) equal to 9 minus square root of 3x plus 3. So we want to find the value of C for the given interval of 2 and 11. Okay, so for this function, so first of all, when you get the question, okay, like our Rolle's theorem previously, so first of all, first step, you must write down back the given function, which is f(x) must be equal to 9 minus square root of 3x plus 3 for the given interval 2 and 11. So this is the given function and interval to us. So you just write down back. Okay, so the second step is like the Rolle's theorem. We substitute our given function, replace the value of a with the given interval, which is our a is equal to 2. So we find our f2, means from the given function of f(x), we just replace the value of x with 2 here. So what happened to our function? We will get 9 minus square root of 3 times 2 plus 3. So when we solve for it, okay, 3 times 2, 9, 9 plus 3, 3 plus 2, 6, 6 plus 3, 9. So 9 minus square root of 9, then we will get 9 minus 3, which is equal to 6. Okay, so this is our FA, which is F2 equal to 6. Okay, then we solve for our FB, we just replace the value of B, which is our B is 11 here. So we just substitute the value of 11 into the given function of f(x) above. Then we will get our f11 is equal to 9 minus square root of 3 times 11 plus 3. So 3 times 11, 33 plus with 3, then we will get 36. So square root of 36 is 6. So 9 minus 6 is equal to 3. So we will get our FA equal to 6 and FB equal to 3. Okay, so what is the difference between mean value theorem and Rolle's theorem? If you look at here, our value for FA not equal to value of FB, but in Rolle's theorem, the value for FA must be equal to FB. So you need to identify this first in order to know which is the suitable theorem. You need to know whether mean value theorem or Rolle's value theorem. So the difference you can get from this step, okay, which is FA must be equal to FB for the Rolle's theorem, but for the mean value theorem, the value of FA not equal to FB. Okay, so next, the third step, you must differentiate that given function. Okay, so from the given function of f(x), we differentiate 9, we will get 0 because 9 is a constant. Then we differentiate square root of 3x plus 3. Okay, to make it easy, you put the square root for the given function above, then you will get the power of 1 over 2. So the power of 1 over 2 we can put in front. Okay, you put the power of 1 over 2 in front, you differentiate as usual. Okay, so when we differentiate square root of 3x plus 3, so the power itself we come to in front, so it will give you 1/2 times with 3x plus 3. Okay, so power above 1/2 minus 1. Okay, 1/2 minus 1, then we will get negative 1/2 times with the differentiable at the column here. So 3x plus 3 we differentiate and we will get 3 here. Okay, so we solve for it. 1/2 in front multiply with 3 at the end here. So we will get negative 3/2 times with 3x plus 3 power of negative 1/2. Okay, so from here, because of negative here, so we need to bring at the bottom the function. So it will become f prime x is equal to 3 negative 3/2 square root of 3x plus 3. Okay, so from this function, you will find your f prime c. Okay, how to find your f prime c? You just replace the value of x with c, then you will get f prime c is equal to negative 3/2 square root of 3c plus 3. Okay, so from this function, okay, so you will use the formula of f prime c is equal to fb minus fa over b minus a. Okay, so you put back the value of f prime c here, which is negative 3/2 square root of 3c plus 3 equal to fb minus fa. Okay, fb that we have find previously, which is fb is equal to 3 and fa equal to 6. Okay, so you just replace FB 3, FA 6 here over B minus A. So the value for B is 11, A is 2. So 11 minus 2. Okay, so we solve for the left hand side and right hand side. We simplify this. We will get for our right hand side negative 3/9. So we simplify negative 3/9, then we will get negative 1/3. Okay, so from here you will cross multiply. Okay, cross multiply 3 at the bottom at your numerator, multiply with 3 at your denominator here, and 2 square root of 3c plus 3 at your denominator. Okay, multiply with 1 at your numerator here. So from here we will get 9 equal to 2 square root of 3c plus 3. Okay, so we want to make our C as a subject. So you reorder or rechange, okay, which is we will get square root of 3c plus 3 must be equal to 9/3. Okay, so square root here, okay, this is square root. So how to make the square root? How to delete the square root. Okay, so we bring the square root to the right hand side, so we need to square. Okay, so we need to multiply with 2 here in order to make our function of C as a subject. So since we multiply by 2 at our right hand side, so at our left hand side also need to multiply by 2 here. Okay, so that's why we will get 9 to the power of 2 is equal to 81 and 2 to the power of 2 is equal to 4. Okay, so this we can cancel square root at our right hand side. So we will get 3c plus 3 is equal to 81/4. Okay, so from here we will get c is equal to 23/4. Okay, so 23/4, or if we change the fraction to decimal place, so the value of C that we get here is 5.75, which is 5.75 must be subset for 2 and 11. Okay, so the value that you have get at the end of your solution must be in the interval given in the question, which is in between 2 and 11. If you get the value at the end of your answer is not in the interval, that means your answer must be wrong or anything else lah. Okay. Chapter 4 will cover the topic of antiderivative and the indefinite integral. Okay, so antiderivative is actually integration. Okay, integration. So what is the meaning of antiderivative? Okay, antiderivative is the inverse operation of the derivatives. Mean if you previously have learned about the differentiation, so now the reverse from differentiation means we want to make our differentiation function into the original function of f(x). So we name it as antiderivative or integration. So it's also we can call it as a backward operation, okay, which is the from derivative you have a function of f(x). Okay, f(x), you find your differentiate that function, then you will get f prime x. So from f prime x, we want to find the original function of f(x) back. So we call it as antiderivative or inverse operation or backward operation, or familiar with the integration operation. So mathematically, the antiderivative of a function interval is state that f prime x is equal to f(x). Okay, so for all of x and the interval of I. Okay, so then the antiderivative for f must be subset for the closed interval of ab, which is f(x) if and only if f(x) is continuous function and closed interval of ab, okay, which is f prime x must be equal to f(x) and x must be in the interval of a and b. Okay, so the commonly name we use as indefinite integral. Okay, so let we look at the example here. Okay, so integration. Okay, so this is the step of integration. Okay, which is the reverse. If you find previously you have learned about the integration. Sorry, if you have learned previously about differentiations, so differentiation is dy over dx, then you will get that function of differentiation. So from dy dx, we want to find our f(x) back by using the integration symbol. So from y to b dy dx, we differentiate, and from dy dx, we want to find our y, we need to integrate. So the symbol of integration is like this. Okay, macam cacing. Okay, it's used to indicate the integration process. Okay, so we have several formula in order to find our integration for the given function. Okay, so first is integration of a constant. Constant is any number when you press your calculator that the number will appear in your calculator. That's we call it as a constant. So like 2, 1, 3, doesn't matter whether that number is fraction, decimal place, square root, as long as that value can appear in your calculator, so that we call it as a constant. So how to integrate the constant? The formula to integrate the constant is integration of k dx. Okay, if you look at here, the constant of k, we didn't have any x here. Okay, but you need to differentiate to dx, but we didn't have any x at our integration function here. So means if you didn't have any x at your function given here, means that is we call it as a constant. So when we differentiate constant, we just plus or we just multiply the constant with x. Okay, so it will become the answer for integration of k, we will become kx plus c. Okay, so let we look at example 1 here. So all the given example here. Okay, for the number 1, a equal to 5. So 5 is the example of a constant. So when we integrate 5, we just write down the integration of 5 dx equal to 5x plus c. Okay, so when we integrate negative 2, we will get negative 2x plus c. When we integrate 1 over 10, we will get 1 over 10x plus c. And square root of 3 also a constant. Okay, so when we have any constant, you no need to change that constant. Okay, you just write down the constant of square root of 3 here, and you just add x here. Okay, so the answer of integration square root of 3 dx here, you will get square root of 3x plus c. Okay, so this is the step how to solve for integration of a constant. Okay, second, if you have any x, any variable x to the power of n, okay, it not only x. Sometimes it can be others variable like k, y, z. So whatever the variable given to you, okay. So the formula to integrate that variable to the power of n is integration of a x to the power of n dx. Okay, so this to solve for x to the power of n. So what happened? So your n, okay, your power must be plus with 1 here. Okay, plus with 1 and plus 1, and the above at the power must be same with your denominator. Okay, so n plus 1 at the power and n plus 1 also at the bottom, and don't forget to write down plus c at the back. Okay, so where a and c are the constant, and the value of n must be not equal to 1. Why not equal to negative 1? Okay, if your n is equal to negative 1, so your denominator becomes 0. So when your denominator becomes 0, and when you solve it, you will get undefined function. Okay, so let me look at the example 2 here. So we are given integration of 3x to the power of 5. Okay, so 3 is a constant. You don't need to change anything with 3. You just write down back the value of 3. Okay, so x to the power of 5. When we integrate x to the power of 5, so the power itself must plus with 1. So 5 plus 1 at the power, and 5 plus 1 at the denominator also. So it will become 3x to the power of 6 over 6 plus with c. Okay, so when you get here 3 over 6, you can simplify, right? So you need to simplify first. So 3 over 6, you can simplify by your own, or you can press your calculator. Then you will get 1 over 2. So we solve for this function, and we will get x to the power of 6 over 2 plus with c. Okay. So next example, integration of 3 over ax to the power of 2 dx. Okay, so 3 over a is the constant. So you just left 3 over a in front. Okay, don't change anything with the given constant. You just only integrate the function. So our function in this example is x to the power of 2. Okay, no need to change anything with 3 over x here. Please don't change anything with 3 over x. Okay, so what we need to do here, only integrate x to the power of 2. So as I mentioned previously, the power must be plus with 1. So 2 plus 1, you will get 3, and the power itself must be equal to the denominator. So 2 plus 1 at your power, and 2 plus 1 also at your denominator. Please remember, don't change anything with the constant in front. 3 over 8, you just write down back the amount of 3 over 8. Then multiply with the integration of x squared. Okay, when we integrate x squared, we will get x cubed over 3 here. Okay, so when we multiply, we can cancel 3 at denominator and numerator here. Then we solve for it, we will get the integration of 3 over 8x squared. We will get x cubed over 8 plus with c. So this is the example 2b. Okay, next, example C. Okay, we have 0.75 here. So 0.75 is a constant. So any constant that you have, no need to change that constant. What you need to integrate only the variable here. Please remember. Okay, so x to the power of 4, when we integrate, just plus 1 at the power. So 4 plus 1 at the power, and same with your denominator, also 4 plus 1. So what happened to the function? Okay, 0.75 is a constant. You just write down back and you solve for 4 plus 1, you will get x to the power of 5. So denominator also 4 plus 1, which is 5. Okay, so you just press your calculator, 0.75 divided by 5, and you will get 0.15 x to the power of 5 plus c. Please don't forget to put plus c at the end of your solution. Okay, so for example D, integrate of negative square root of 5 x. Okay, please remember the value of variable x here is outside from your square root of 5. So negative square root of 5 we can put in front. Don't change anything with the constant of negative square root of 5. Okay, what you need to integrate only x to the power of 1. Okay, so when integrate x to the power of 1, we will get x to the power of 2 over 2. Okay, plus c. Okay, so we cannot simplify square root of 5 over 2 here. You just left your answer until here. If you want to put in decimal place also can, but just left until this is okay. Integral of ax plus b to the power of n. Okay, so when we want to integrate ax plus b to the power of n dx. Okay, so what happened to our integration here? Okay, first of all, you just write down back the given function of ax plus b to the power of n here. Okay, so you just plus with 1 for the power. So n plus 1 at the power, bring to the denominator. So n plus 1 also at your denominator, plus with the integration. Plus with the differentiation of ax plus b. So when we differentiate ax plus b, we will get a here because b is our constant, right? When we differentiate constant, we will get 0. Okay, so from here, our integration of ax plus b to the power of n, we will get ax plus b power of n plus 1 over n plus 1 multiply with the value of differentiation for ax plus b, which is a, and don't forget to put plus c at the end of your answer. Okay, which is n must be not equal to negative 1. Okay, example 3. Integration of x plus 3 to the power of 4 dx. So what we need to do is just plus with 1 at the power here. So 4 plus 1, it will become 5 here. Okay, so 5 at the top at the power must be also at your denominator. And we solve for x plus 3, we differentiate x plus 3, we will get 1 here. So f plus 1 is 1, s is 5. So the answer for this integration is x plus 3 to the power of 5 over 5 plus c. Okay, b, integration of 1 minus x to the power of 3 dx. Okay, so we need to add 1 at the power here. So 3 plus 1, it will become 4. Okay, so 4 at the power, we write down at the denominator. So 4 multiply with the differentiation of 1 minus x. Differentiate of 1, we will get 0. Differentiate of negative x, we will get negative 1. So we solve for it, we will get 1 minus x to the power of 4 over negative 4 plus c. C, when we want to integrate 5x plus 4 to the power of 7 plus 7 dx. So the value of 7 here we add with 1. Then it become 8. Okay, so 8 times with 5. So we will get 5x plus 4 power of 8 over 40 plus with c. Okay, so because 8 plus 5 is equal to 40. 5 we get from the differentiation of 5x plus 4. D. Integrate of 1 over square root of 2x plus 5. Okay, so when you have a function at the denominator, so you put your denominator to up. Okay, it's become your numerator. So when we change our denominator to become numerator, so the power we have negative here. So negative 1 over 2. Okay, so we need to integrate 2x plus 5 to the power of negative 1 over 2. So the power itself must be plus with 1. Okay, so negative 1 over 2 plus 1, and we will get 1 over 2. Okay, so the power itself must be also same at the bottom. So 1 over 2 multiply with the differentiation of 2x plus 5. Okay, so when we differentiate 2x plus 5, we will get 2 here. So 1 over 2 multiplied by 2, we will get 1 at the denominator. So the function for integration of 1 over square root of 2x plus 5, we will get square root of 2x plus 5 plus c. So this is our last answer. Okay, so example 5, integration of 2x power of 4 plus 2x power over 5 minus 3. Okay, this function, we didn't have any power at outside of our bracket. So we just integrate one by one. It's only involve positive plus and minus operation. It's only involve positive integration of 2x power of 4 plus 2x over 5 minus 3. So when we integrate 2x power of 4, okay, please remember 2 is a constant. So we just integrate x to the power of 4, then we will get x to the power of 5 over 5. So we will get to x power of 5 over 5 plus with integrate x, we will get x squared. Okay, x squared. This is actually what we will get is 2 over 5 is a constant. Don't change anything. But when we integrate x to the power of 1, we will get x to the power of 2 over 2. But when we simplify 2 over 2, we can cancel. That's why we will get x squared over 5. And we integrate negative 3 here, we will get negative 3x plus c because 3 is a constant. Okay, so next, when we integrate 3x minus 2 to the power of 2 dx. Okay, first we need to expand this bracket first. So when we solve for 3x minus 2 square at the power, we expand first, then we will get 9x squared minus 12x plus 4. So from here we integrate. So integrate 9x squared, we will get 9x cubed over 3. Integrate 12x, we will get 12x squared over 2. And when we integrate 4, we will get 4x plus c. Okay, then we simplify this. 9 over 3, we will get 3. 12 over 2, we will get 6. And we integrate 4x, we will get 4x. Okay, so the final answer, don't forget to simplify each answer. So we will get 3x cubed minus 6x squared plus 4x plus c. Okay, c, when we integrate x to the power of negative 3 plus 2x, we will get, okay, negative 3 plus 1 is negative 2 over negative 2. So x squared over 2, we integrate we simplify this 2 over 2, we will get 1. So we solve for it, we will get negative 1 over 2x squared plus x squared plus c. Example 5. Okay, square root of x. Okay, so when you have a question of square root, please change the square root into the power first before you integrate. So square root of x means x to the power of 1 over 2. So from here, then you integrate x to the power of 1 over 2, then you will get x to the power of 3 over 2 over 3 over 2 plus with c. Okay, so when we integrate this one, okay, we solve for it, then we will get because of 3 over 2 at your denominator, you have many of divider here. Okay, so you need to put 3 over 2 or 2 at the top. Okay, so when we simplify this, we will get 2x to the power of 3 over 2 over 3 plus c. Okay, next, b. Okay, b is cube root of x plus times with 2 plus x. Okay, so this one, as previously, when you have any root function, you just change to the power, so it will become x to the power of 1 over 3 multiplied with 2 plus x. Okay, so from here, you expand the given function first. Okay, expand one by one. Okay, so when we expand this bracket, we will get 2x to the power of 1 over 3 plus with x to the power of 4 over 3. How we get 4 over 3 here? Because x power of 1 over 3, okay, so if we expand x to the power of 1 over 3 multiply with x, okay, so the index of log, so when multiply it will become plus. So x power of 1 over 3 plus with 1. Okay, so 1 over 3 plus 1. So that's why we will get x to the power of 4 over 3. Okay, remember this only you expand the bracket, you not integrate the bracket yet. Okay, so from here that you integrate 2x to the power of 1 over 3. How to integrate? So 1 over 3 plus with 1. So then you will get 4 over 3 at the top. Okay, at the power. Then power and denominator must be same. Okay, so when you integrate 4 over 3 for the power of x, then you will get 7 over 3 here. So must remember your power and your denominator also must be same. Okay, then you simplify. Okay, so 4 over 3 divide, and when we multiply, it will become 3 over 4 multiplied with 2x to the power of 4 over 3. Okay, plus with 3 over 7x to the power of 7 over 3 plus c. Okay, so when we simplify this, we will get 3 over 2x to the power of 4 over 3 plus 3 over 7x to the power of 7 over 3 plus with c. C, integration of 3 over square root of x plus 1 over x cubed plus minus 2x. So please change the square root symbol here to the power. So you will get 3 over x to the power of 1 over 2 plus with 1 over x cubed minus 2x. Okay, so when we bring our x power of 1 over 2 to the top, so it will become x to the power of negative 1 over 2, and x power of 3 we go to the top, and it will become x to the power of negative 3 minus 2x. Okay, so negative 1 over 2, when we integrate, we will get negative 1 over 2 plus 1. So the power will give us 1 over 2, and same with the denominator. Okay, please remember, no need to change anything with 3 here because 3 is your constant. So you will get 3x to the power of 1 over 2 over 1 over 2. Okay, then we integrate x to the power of negative 3. Negative 3 plus with 1, we will get negative 2. So the power and denominator is same. So you will get x to the power of negative 2 over negative 2 minus 2x to the power of 2 over 2 plus c. Okay, so when we simplify this, so 3 over 1 over 2, it will give us 2 over 1 multiply with 3x to the power of 1 over 2. Okay, plus and minus here, you just simplify, then you will get negative x to the power of negative 2 over 2 minus, okay, 2 over 2, we can simplify also, then we will get x to the power of 2 plus with c. Okay, so when we simplify here, we will get 2 times 3, okay, which is 2 times 3 is 6, okay, 6 times square root of x, okay, because x to the power of 2, we change and we will get square root of x here. Okay, so x to the power of negative 2 at the top, we go to the bottom, so we will get 1 over 2 x power of 2 minus x to the power of 2 plus c. So this is our last answer. Okay, so you just remember, please no need to change with the constant. What you need to integrate only the variable itself. Okay. Okay, next we will learn about the integral of trigonometric function. Okay, so from here we have 6 laws of integral trigonometric function. Okay, so the first one, when we integrate sine Ax, okay, Ax is the angle for this sine. Okay, so what given to you is when we integrate sine, we will get negative cos. Okay, negative cos. Okay, A is the angle, must be same. No need to change anything with the given angle. You just write down same exactly with the given question. Okay, when you are given AX, then the angle after integrate also AX. Okay, at the bottom is the value when you differentiate that angle. Okay, so for example, you have an angle of AX. So when you differentiate AX, you will get A here. Okay, so if we bring A in front, so we will get negative 1 over A cos AX plus with C. Okay, number 2. Integration of cos Ax. Okay, so when we integrate cos Ax dx, we give a sine Ax. Okay, it's same with the first step here. Okay, don't change anything with the given angle. You just write down with the previous given information or given question. Okay, if you are given Ax, so the value of Ax here maintained. The change only at the trigo, which is integration cos, you will get sine. Okay, at the bottom, which is your denominator, it comes from the differentiation of Ax. So when we differentiate Ax, because of A is a constant and X is the power of 1, and when we differentiate, we will get A here. Okay, so we simplify this, we put our A in front of our integration, then we will get 1 over A sine Ax plus with C. Okay, so this is the answer for integration of cos Ax dx. Number 3, when we integrate secant square of Ax dx, we will get tangent Ax over the value of integration of Ax. Okay, so integration of Ax, we will get A here. Okay, so then we will get 1 over A tangent Ax plus with C. Okay, number 4, we integrate cosecant square Ax. Okay, cosecant square Ax dx, when we integrate, we will get negative cotangent Ax. Okay, A is the value from the integration of Ax. Okay, plus C. So when we put the value of A in front and we will get negative 1 over A cotangent AX plus C. Rules number 5. Secant AX tangent AX. So when we integrate secant AX tangent AX, we will get secant AX over the value for differentiation of AX is A. So when we solve for it, we bring our constant in front and we will get 1 over A secant AX plus with C. Okay, number 6, rule number 6 is integration of cosecant AX cotangent AX dx. So when we integrate this, we will get negative cosecant AX over A, which is A is the differentiation of AX, and we bring the constant in front, then we will get negative 1 over A cosecant AX plus with C. Okay, we look at example 6. Find sine 6x. Okay, so sine 6x, look the rules that we have here, which is when we integrate sine, we will get negative cos. Okay, so please remember the angle must be same with the given angle at the question. So since we are given 6x here, so the angle of 6x also comes at your answer. Okay, so at your denominator, you must differentiate your 6x. So when we differentiate 6x, we will get over 6 here. So then we simplify by bring the negative 1 over 6 in front. So our final answer is negative 1 over 6 cos 6x plus with C. Number B. Integration of cos 2 minus 5x dx. So when we integrate of cos, look at our rule here. We integrate cos, then we will get sine. Okay, so the angle must follow the original angle, which is 2x minus 5x. Okay, the denominator comes from the differentiation of 2 minus 5x. Okay, 2 is a constant. When we differentiate, we will get 0. Negative 5x, when we differentiate, we will get negative 5 here. So you rearrange back your answer, then you will get negative 1 over 5 sine 2 minus 5x plus with C. C, integration of secant square 3x dx. Okay, so look at the rule here. When we integrate secant square, and we will get tangent of AX. Okay, so our answer, we will get tangent of 3x over 3. Okay, 3 comes from the differentiation of 3x. Okay, so we simplify this by bring the denominator in front, and we will get 1 over 3 tangent 3x plus with C. Okay, next, we integrate secant 2x plus 1 tangent 2x plus 1. Okay, this trigo, we have two same angle, which is 2x plus 1. Okay, so look at our rule here, which is secant AX tangent AX dx. So when we integrate this function, it will give a secant of 2x plus 1 over the differentiation of 2x plus 1, then we will get 2 here. Okay, so we bring 2 at the denominator in front, and we solve it, we will get our final answer is 1 over 2 secant 2x plus 1 plus C. Integrals of exponential and logarithmic function. Okay, if you have integration of E stands for exponential. Okay, with the power of Ax plus B. So what happened to your answer is, first of all, you need to write down back the given information to you, the given question. Okay, so at your numerator, you just follow the original given question, which is E to the power of Ax plus B. Okay, over at your denominator is equal to the differentiation of ax plus b. So when we differentiate ax plus b, we will get a here. Okay, so next, last final answer, you need to bring your denominator in front, then you will solve, you will get 1 over a times with e to the power of ax plus b plus c, which is our a, b and c are constant. Example 7. Okay, example 7, if we have e to the power of x. Okay, so follow the rule for exponential of integration. So first we need to write down back the original given function. Okay, so our given question is ex, so you just write down ex, e power of x. Okay, over the differentiation of power. So our power is x. When we differentiate x, we will get 1. So that we will get the integration of e power of x is equal to e power of x plus c. So just left your final answer until here. B, e to the power of 2x plus 3. Okay, so when we integrate this, what we will get is first we just write down back the given question, which is e to the power of 2x plus 3 over the differentiation of 2x plus 3. Integration of e power of 2x plus 3. So when we integrate exponential, so we just write down back the original function, which is e to the power of 2x plus 3 over our denominator here must be the differentiation of the power itself. So when we differentiate 2x plus 3, then we will get 2 plus c. So we rearrange back our final answer and put the denominator in front, and we will get 1 over 2 e to the power of 2x plus 3 plus c. Then c, integration of e to the power of 1 minus 4x dx. Okay, so first of all, we just write down back the given function, which is e to the power of 1 minus 4x over the differentiation of negative 4x, and we will get negative 4 here. Okay, so the answer is we put negative 4 at denominator in front, and we will get negative 1 over 4 e to the power of 1 minus 4x plus c. Integral of 1 over ax plus b without power. Okay, so when you have a function and the denominator is the variable b without power, so what happened to the integration? So when you integrate 1 over ax plus b, is become ln ax plus b over a. Okay, a is the value of a comes from the integration of ax plus b. So when you integrate ax plus b, then you will get a here. Okay, and don't forget to plus c at the end of your answer. Okay, so as usual, you need to bring your denominator in front, then your final answer, you simplify, it's become 1 over a ln ax plus b plus c, which is your a, b and c are constant. Okay, example 8. Okay, find 1 over x. Okay, so 1 over x, when you integrate, okay, x, we didn't have any power at x, so what happened to integration? So it's become ln x plus c. Okay, you need to remember when your integration become ln, when your denominator is the variable itself didn't have any power of x, such as x power of 1 only. So this integration only will become ln. If your variable x have a power, you cannot get ln. Okay, so remember, when you integrate the variable at your denominator with the x power of 1 only, the answer we get ln. Okay, so the answer of 1 over x is ln x plus c. Okay. So b is integration of 1 over 3x. Okay, so 3 is a constant. You just put ln in front, follow with modulus of 3x. Okay, over 3. Okay, 3 comes from the differentiation of 3x. When we differentiate 3x, we will get 3 here. So plus with c. So 3 we put in front and rearrange, we will get 1 over 3 ln 3x plus c. Okay, c, we integrate 1 over x plus 7. Okay, so when we integrate 1 over x plus 7, we will get ln modulus of x plus 7. Since our variable of x is, we didn't have any constant in front of x. So when we differentiate x, we will get 1. We differentiate 7 also, we will get 0. So we no need to put anything at denominator, because when we differentiate x plus 7, okay, we will get 0 here. Okay, or 1, we will get 1. So the final answer of integration 1 over x plus 7 is equal to ln x plus 7 plus with c. Okay, next, d, integration of 1 over 2 minus 3x. Okay, so you just put ln modulus of 2 minus 3x. Okay, over the integration of 2 minus 3x is equal to negative 3. Because 2 is a constant, when we differentiate constant, we will get 0. And when we differentiate negative 3x, we will get negative 3 plus with c. Okay, so then we rearrange back the question. Our answer should be negative 1 over 3 ln 2 minus 3x plus c. So just left your answer until here. 4.3, definite integral. So previously we have learned about indefinite integral. Okay, indefinite integral is the integration. We didn't have any value at your integration symbol like this. We didn't have any integration value. Okay, so means your final answer should be in term of variable and constant. But for definite integral, you have a specific amount, a specific value for the interval of integral. Okay, like this. If you have a function of fx and you have the interval from a to b, you have a limit for the integration. From when to where you want to integrate that function. Okay, so we look at example 9 here. Okay, so example 9, we have a function of square root from 1 to 2. Okay, we read how to read this. We read from bottom to top. Okay, so integration from 1 to 2, x minus 2 multiply with x cubed plus 5x. Okay, so first of all, you need to expand one by one first. You need to expand one by one. So when x multiply with x cubed, we will get x power of 4. Okay, x multiply with 5x, we get 5x squared. Okay, then we expand negative 2 multiply with x cubed, we will get negative 2x cubed. Okay, 2 multiply with 5x, we will get negative 10x. Okay, so from here we expand. After expand, we integrate. Okay, so this is only expand from the above function. Okay, then we integrate one by one. Okay, we integrate x to the power of 4. Remember, when we integrate x power of 4, we just add the power of 4 with 1. So it's become x power of 5 over 5. Okay, 5x square when we integrate is become x power of 3. Okay, because 2 plus 1 is equal to 3. So the power will be same with the denominator. So that you will get 5x to the power of 3 over 3. Okay, 2x cubed when we integrate, we will get 2x to the power of 4 over 4. Okay, then when we integrate 10x, it will get 10x squared over 2. Okay, so from here, you just left your your bracket with 1 at the bottom and 2 at the top. Okay, it's same with the original question from 1 to 2. Okay, so from here, you just simplify first. Which one is you can simplify? So 2 over 4, you can simplify. It's become 1 over 2. 10 over 2 also you can simplify, you will get 5 here. Okay, so after simplify, then you substitute the value of x with 2 first, then minus with the value of x when we substitute x with 1. Okay, so you count one by one, you just press your calculator, substitute for x with 2 first, which is 2 power of 5 over 5, plus 5 times 2 power of 3 over 3 minus 2 power of 4 over 2 minus 5 times 2 power of 2. Okay, so when we solve for the first bracket, we will get negative 1 to 4 over 15. Okay, for the second bracket, when we substitute our x with 1, okay, we just replace 1 by 1. 1 to the power of 5 over 5 plus 5 times 1 to the power of 3 over 3 minus 1 to the power of 4 over 2 minus 5 to the times 1 power of 2. So when you press your calculator, you will get negative 109 over 30. Okay, so we simplify this, then we will get negative 139 over 30. Okay, number B, you need to integrate from 1 to pi for the function of e power of 2x plus cos 2x minus 3 over x. Okay, so you integrate one by one. Okay, so it's involved 3 different functions here. The first one is exponential, e. Second one is trigo, cos. The third one is logarithmic. But doesn't matter whatever function you are given, you just solve one by one. So the first step is solve for exponential e to the power of 2x. So when we integrate exponential, remember you need to write down back the original given function, which is you are given e power of 2x. So you just write down back e power of 2x over the differentiation of 2x. Okay, so differentiate 2x, we will get 2. Okay, remember the denominator of exponential must be the differentiation of the power. Okay, so next, when we differentiate we integrate cos 2x. Okay, remember the rules for integration of cos 2x. When we integrate, we will get sine 2x over the differentiation of 2x is equal to 2. Okay, minus with 3. Okay, 1 over x. Okay, 3 is a constant. So you no need to change anything with 3 because it is a constant. Okay, but you only need to integrate 1 over x here. Okay, remember back the rules for logarithmic. When you integrate logarithmic function, so 1 over x is become ln x. Okay, so the question want you to integrate from 1 to pi. Okay, so after you get the integration here, you just replace the first thing with pi. Okay, just substitute the value of x or value of x with pi. And the second one, you just substitute the value of x with 1. Okay, so when we solve for this, we will get our answer is 260.16. Number C, integrate from 4 to 9, 1 minus square root of x over x squared dx. Okay, so integrate from 4 to 9, 1 minus x to the power of 1 over 2 over x squared dx. Okay, so if you get this question, first step you need to separate one by one first. Okay, so when we separate, we put our denominator for the first one first and also for the second one. So when we separate, we will get 1 over x squared minus x to the power of 1 over 2 over x to the power of 2. Okay, so after you separate, then you need to simplify this. Okay, so remember when you have a function at the bottom, okay, our x have a power of 2. So please don't put lone because the x, okay, we have x to the power of 2. If your x is power of 1 only, we can bring and become lone. Okay, so because of x to the power of 2, so you need to bring the denominator x power of 2 to the top and it will become x to the power of negative 2. Okay, same goes to x to the power of 2 at your right hand side. So when we go to the top, it's become minus. Okay, so at our top, we already have x to the power of 1 over 2 here. Okay, so when we solve and we bring our denominator to numerator, so it's become, because the power of index, so 1 over 2 at your numerator. Okay, 1 over 2 will minus with 2. Okay, 2 because the power of denominator is 2. That's why you will get 1 over 2 minus 2 is equal to negative 3 over 2. Okay, so from here, this is your solving first. You not simplify, you not integrate yet. Okay, so from here, then we integrate x to the power of negative 2. Okay, remember the step to integrate, we just plus 1. So negative 2 plus with 1. Okay, that's why we will get negative 1 here. Negative 1. So our answer for the first one is x to the power of negative 1 over negative 1. Remember, the power itself must be equal with the denominator. Okay, then second one is power of negative 3 over 2. So 3 over 2 when we plus with 1. So negative 3 over 2, we plus with 1. So what happen is we will get, just press your calculator, then you will get negative 1 over 2. Okay, so the answer is x to the power of negative 1 over 2. Okay, then remember the power and denominator must be same. So the answer is x to the power of negative 1 over 2 over negative 1 over 2. Okay, so then you simplify x to the power of negative 1 over negative 1. Okay, so then you will get negative 1 over x. Okay, so minus symbol here, minus and minus. Okay, so minus times minus, then we will get plus. That's why your answer is plus here. Okay, so plus with 2x to the power of negative 1 over 2. Okay, since the power of x is negative, so you need to rearrange and bring x to the power of negative 2 to the bottom. Okay, so your answer is negative 1 over x plus 2 over square root of x. Okay, it's not the final answer yet because this is definite integral and you need to solve until you get the value for the integration. Okay, so then this is the answer and you just substitute this function, this final answer with 9 first. Okay, so our x become 9 now. Negative 1 over 9 plus with 2 over square root of 9. Okay, at the back, negative 1 over 4 plus with 2 over square root of 4. Okay, So when we simplify this both, we will get 5 over 9 minus 3 over 4. Okay, then we will get 7 over 39. Okay. Properties of integration. We have 6 properties of integration here. Okay, so the first properties is integrate from b to a for the function of f as dx. Remember, when you want to split for the function, you need to read from the bottom to the top. Okay, so when we integrate for the function of b to a f as dx, and we want to change the definite integral here. Okay, we want to put our b at the top and our a at the bottom. So it will become negative of integration from a to b. Okay, so please look at your integration symbol. Indefinite integral is changed. Okay, previously from b to a, and then when you want to change from a to b, you need to add negative sign in front of the function of f as dx. Okay, properties number 2. Properties number 2 is you want to integrate for the function of f as dx from a to a, because the value of the function from top to bottom is same. Okay, such as you have from 1 to 1. Okay, from 1 to 1 or from 2 to 2. Whatever value, when you have the same value at the bottom and top, and when you integrate, you will get the value for the function is equal to 0. So this is the second properties of integration. Okay, the third properties for integration is integrate from a to b fx plus gx dx. Okay, so you need to integrate from a to b fx dx plus with integrate from a to b gx dx. Okay, means these two functions you separate into two different functions. Okay, but the integration of definite function must be same from a to b, from a to b. Okay, properties number 4. Okay, is properties number 3 we have plus here. Okay, but properties number 4 we have minus, but it's same like properties number 3. You just change the symbol of plus to minus only. Okay, so when we solve for integration of fx minus gx from a to b, so it's become integration of a to b fx dx minus integration of a to b gx dx. Properties number 5. If we have a function of k fx dx integrate from a to b, okay, so k is a constant. Okay, so the constant you can bring in front and out from the integration symbol. So what happened to the function? You need to integrate the function with the variable of x only. So means here you no need to change anything with the constant of k. Okay, you just integrate the function of fx from a to b fx dx. Okay, when you are given the function with the constant of k, so just put k in front out from the integration symbol. Properties number 6. If you have the integration from a to b fx dx and you want to add the one value for the given interval from a to b, you want to add one value here. Okay, so you integrate from a to b fx dx plus a to c fx dx, mean b here must be cross. Okay, cross. Okay, so integrate from a to c fx dx equal to integrate fx from A to B plus from B to C. Okay, so A to C actually we have at the top is C. Okay, at the bottom is B. So when we simplify, it's become integration of fx dx from A to B back. Okay, example 10. Okay, example 10. When we want to solve for the integration of fx from -1, 5, you are given fx from 1 to 5 dx is equal to -5, and you are also given gx dx from 1 to 5 is equal to 8. Okay, so the first question, we want to solve for the function of fx plus 2x from 5 to 1. Okay, so first we need to use the properties above in order to solve this problem. Okay, so we need to separate first. Okay, separate the given function first. We have two different functions first. Okay, so the first one, our function is fx. The second function is 2x. Okay, so the function of fx, we put the first one. Okay, so fx from 1 to 5, -1 in front, minus with integration from 1 to 5 to x dx. Okay, so we already given in the question. Okay, we put negative here because we want to change the original given function. Okay, we are given from 1 to 5, but we want to write down from we are given the question 5 to 1, but we want to follow the given information to us, which is 1 to 5. So that's why we need to add negative symbol here. Okay, so integrate negative from 1 to 5 fx minus, okay, because when we open the bracket, it's become minus for both negative of fx and negative also for 2x. Okay, so 2x we can integrate as usual. We just integrate 2x. Okay, so 2x we integrate, we will get x to the power of 2 over 2. Okay, from the given information to us, we already know when we integrate from 1 to 5 fx, we will get -5 here. Okay, -5, you just substitute with -5 in the bracket, multiply with negative in front, then you will get 5 here. Okay, then we simplify for the 2x squared over 2, and we will get x squared. Okay, so from x squared, we have the value of definite integral is 1 to 5. Okay, so you just replace the variable of x with 5 and minus with 1 square. Okay, so 5 square is 25, minus with 1 square is 1. We solve for it and we will get 5 minus 24 is equal to -19. B, we want to integrate from B fx plus 5gx from 1 to 5. Okay, so 1 to 5 is already given to us at the given question. Okay, so we don't need to change with the power of indefinite integral here. Okay, so first we separate both functions because we have two different functions right here. Okay, so the first is our fx, the second is our gx. And in front of gx, we have a constant of 5. Okay, so remember when we have a constant, followed by the properties number 5, we just put the constant in front. Okay, so then we will get integration of fx from 1 to 5 dx. Okay, plus with 5. Okay, 5 from the given information to us, which is 5 is a constant, so we only integrate the function of dx from 1 to 5. Okay, so we know the function of fx integrate from 1 to 5, the value is -5. Okay, so we just replace -5 here. Okay, so 5, the value for integration of gx dx from 1 to 5, we already given in the question, which is 8. Okay, so the value of 8, we need to multiply with the constant in front, 5. So 8 multiplied by 5, we get 40 here. So we solve -5 plus 40, and we will get 35. C, Okay, we will get the question of C is 2 multiplied with the function of fx minus k to the function of gx dx. Okay, equal to 6. Okay, so here we need to separate both functions first. Okay, so 2 is a constant fx dx minus k also is the constant of gx dx. Okay, so first step you need to put the constant in front and out from the integration symbol. Case 2 constant put out of integration symbol. Same goes with k, put in front from the integration symbol. So we solve for the first one, okay, which is integration of fx dx from 1 to 5, we will get negative 5. And when we integrate gx ds in the given information to us in the question is equal to 8. Okay, so negative k times with 8. Okay, so we solve for this equation. We will get negative 10 minus 8k is equal to 6. Okay, so negative 8k is equal to 16. Okay, so 16 divided by negative 8 and we will get our k is equal to negative 2 here. Example 11. If integration of fx dx from 0 to 1 is equal to negative 2 and integration of fx dx from 0 to 4 is equal to 1, evaluate x minus 2 multiplied by fx dx from 1 to 4. Okay, so we have two different functions here. You just separate first integration of x dx from 1 to 4 minus with the 2fx dx from 1 to 4. Okay, so first you integrate x. Okay, so when we integrate x, we will get x squared over 2 over 1 from 1 to 4. Okay, so 2, remember 2 is a constant, put out from the integration symbol, so we will get negative 2. Okay, so fx from 1 to 4, we will use the properties of number 6 because in the given function, we didn't have from 1 to 4, but we have from 0 to 1 and 0 to 4. Okay, so if we write down number line here, we have 0, 1 and 4. Okay, 0, 1 and 4. Okay, so 1 is the value or the number in between 0 and 4. Okay, so we just rearrange back. Okay, it's like from 1 to 4 is 1 integrate from 1 to 0. Okay, 1 to 0 function. Okay, plus with the function from 0 to 4 like this. Okay, but we didn't have a function from 1 to 0. Okay, we only have the function from 0 to 1. Okay, we didn't have the function of 1 to 0. We only have 1 to 0 to 1. So we need to change. Okay, we need to change our given function 1 to 0 to 0 to 1. So it's follow the properties number 1, which is when we change from 1 to 0, we change to 0 to 1. So the given function, we need to add negative. Okay, we need to add negative here. So we need to add negative, so that's why it becomes negative here. Okay, so from 0 to 1 fx dx, and we have negative, actually it's positive here because of we change the symbol from 1 to 0 becomes 0 to 1. That's why follow negative, follow rules number 1, properties number 1, and it's become negative here. Okay, so you just replace the value for the given function of fx, integrate from 0 to 4 is equal to 1. Okay, this is given in the information. And then integrate from 0 to 1 fx dx, we get negative 2 here. Okay, so when we substitute, we just press calculator, and then we will solve it. We get the answer is equal to 3 over 2. Okay, so just left your final answer into the number. Okay, so you need to remember when you have a question about definite integral, so you need to solve until you get the final answer is the number, not in terms of variable. For indefinite integral only, you need to solve until you get the number in terms of variable. Okay, so hopefully you understand all the syllabus. Okay.